So this is Ms. Pi, and in this video I'm going to graph two exponential functions, and I will show you how to do the transformations on those. So the first one I'm going to graph is an exponential growth, and for the exponential growth your base number has to be greater than 1, and it doesn't matter what it is. You can use a 2 or 3 or whatever you want, and to start off you want your x to be in the exponent. So that's how you could set it up, and you can honestly pick any number here that's greater than 1. So I'm picking 3 just because. Okay, so now exponential functions give us this kind of curve right here. And I like that curve, and I want to be able to use it for this part of the eagle here. So I need to get this curve, and I need to drag it down, and I might have to shift it over a little bit. Now, unfortunately, exponential functions are not equations that we can just click and drag. So we have to actually do the transformations in the equations themselves. So it looks like I want to get this point here to just go down 1, 2, maybe like 2.5, 2.7 units down. So to do that, I'm going to, at the very end of the equation, I'm just going to put minus 2.7. So if I want to move it down or up, if I want to move it down, I'll subtract at the end. If I want to move it up, I'll add at the end of the equation, okay? And so when I do that, I get this. Now that's kind of in the right area, but you can tell that my curve is not quite right. So I need to stretch it or compress it, and I do that by changing my 3. So let's pick a bigger number than 3. Let's say 5. See what that does. Well, that did the opposite of what I wanted it to do. I wanted it to, this curve here, to kind of go out further like this, to kind of do a vertical compress by kind of squishing it down, but instead it kind of did a vertical stretch by pulling it up more. So obviously instead of having a bigger number, I need a smaller number. So let's go with a 2 instead of a 5. And wow, that looks really close to what I want. It gives the curve of the eagle's stomach really well. And I think that's a pretty good match. So I'm going to stop there on my transformations, and I'm just going to hide the equation. All right, so now I want to show you how to do an exponential decay equation. With the exponential growth, like we had here, my base number here has to be greater than 1. With exponential decay, your base number has to be greater than 0 but less than 1. And it can be a decimal. You could use 0.5, or you can use a fraction like 1/2. And for now, let's just stick with 1/2 and see how it goes. And we're going to, again, put the x in the exponent and then just push enter. So you can see how I have my graph, and it kind of just curves the same way the exponential growth curved, but a reflection across the y-axis. So we're just curving down instead of curving up. So now this curve here, it looks like it will be a good match for this part of my picture here. But I need to move it over, and again, I can't just click it and drag it over to where I want it, so I need to change the equation itself. Now I want to move it to the left. Let's see, if I had this point here just moved over here, I probably need to move it 1, 2, 3, 4, maybe 4.5 units to the left. And to do that, I'm going to come up to my equation, and instead of at the very end of the equation, if I have it at the very end of the equation and I subtract or add, I'm moving it up or down. I'm going to go up in the exponent, and right next to my x, that's where I'm going to add and subtract. Now, if you recall, if you want to shift things to the left, instead of being x minus some number, it's going to be x plus some number. So we're going to do x plus, and I think I said 4.5, right? So let's see what that does. So that definitely moved it over, but it kind of moved it a little bit too far. So we're going to click on it again. Instead of 4.5, let's do 4.25 and see how that works. So that looks pretty good. Now I might want to either move it down or change my curve a little bit, because you can see this part right here is not quite right. So instead of a 0.5, let's try 1/3. So notice I can either do a decimal or a fraction, and wow, 1/3 looks like it matches really good right here. It matches all the way through. I don't quite get this little part right here, but the rest of it looks awesome. So I'm going to go ahead and stop there. And the last thing I'm going to do, because I have my equation where I want it, is I'm just going to hide it. Okay? So that was how to graph exponential decay and exponential growth functions and then transform them.